Today, we're going to be rolling this toy car down this ramp 3 different times. Each time, we're going to take off a book to decrease the height of the ramp. The purpose of decreasing the height is to see how it affects the velocity and acceleration of this toy car.
The independent variables of our experiment would be the mass of the toy car and the height of our ramps. The dependent variables would be the velocity of the toy car, the acceleration of the toy car, and the time it takes for the car to roll down the ramp. First, you'll get your 3 textbooks, your wooden ramp, your toy car, and a timer. You will then place the car at the top of the wooden ramp and start your timer as soon as you release the car. Once the car reaches the bottom, you will stop the timer. You will then record your time in the table for ramp 1. You will then measure the length of the ramp. This will be your distance. After getting the time it took for the car to roll down each ramp, you will then use that time to calculate velocity. Velocity is determined with distance over time. The distance for a ramp was 0.61 meters. Each ramp had a different time. These are our calculations.
After finding velocity from our recorded times, you then use the velocity to find acceleration. To find acceleration, you subtract the final velocity by your initial velocity. You then divide it all by time. These are our acceleration calculations. As you can see, our potential sources of error are either starting the timer too early or too late, and also an additional unintentional force acting upon the toy car. Also, friction and an uneven ramp. These can be fixed with a frictionless ramp and a timer that can be triggered by the toy car. Some limitations of being at home are, again, not having a timer that can be triggered by a toy car, and also not having a meter stick, which we would have used to measure the height of our ramp instead of our measuring tape, which measures in feet, so we don't have to convert from feet to meters. Okay, so for our graph, we have a height versus velocity. In our x-axis, we have height, which is calculated in meters, and then we have velocity in our y-axis, which is calculated in meters per second. This relationship we have in front of us is a directly proportional one, which means that as the height increases, which means more books being added, it means that the velocity also increases. And then we have a height versus acceleration graph, and our height is again in our x-axis, which is calculated in meters, and acceleration is on our y-axis, calculated as meters per second squared. It's a very similar relationship, also directly proportional, which also means that as the height increases, the acceleration increases of the toy car.